In this problem, the man attempts to pull down the tree using the cable and small pulley arrangement shown. If the tension in AB is 90 pounds, determine the tension in cable CAD in pounds and compute the angle phi which the cable makes at the pulley. Now to solve this problem, we construct our free body diagram considering pulley A. Now pulley A experiences a 90-pound force that is exerted by the man, and two tensile forces equal in magnitude. The reason why they're equal is because it came from the same cable, and it is acting at an angle of 20 degrees, and another tensile force acting at an angle of 20 plus phi degrees. Now to solve this problem, we can utilize the equations of equilibrium, that is taking summation force vertical and horizontal. Also, this angle right here is equal to 30 degrees. By the alternate interior angle theorem, this angle of 30 degrees will also be equal to this angle here, which is equal to 30 degrees. So by taking summation force horizontal equal to 0, considering rightward forces to be positive, we have the 90-pound force times cosine of 30 degrees minus the tensile force at the bottom times cosine of 20 degrees minus another tensile force T acting at an angle of 20 plus phi degrees, all equal to 0. This is our first equation. Now taking summation force vertical equal to 0, considering upward forces to be positive, we have the negative 90 downward force sine of 30 degrees plus the bottom tensile force acting at an angle of 20 degrees plus another tensile force sine of 20 plus phi degrees, all equal to 0, and that serves as our second equation. Now that we have our two equations with two unknowns, we can now solve for the variables t and phi. So first, let's manipulate equation 1 to represent t in terms of phi. So we have 90 cosine of 30 degrees plus, factoring out t, we get t times negative cosine of 20 degrees minus cosine of 20 plus phi degrees equal to 0. And manipulating this equation, moving the constant to the right side, we have t times negative cosine of 20 degrees minus cosine of 20 plus phi degrees equal to negative 90 cosine of 30 degrees. So we have t equal to negative 90 cosine of 30 degrees divided by negative cosine of 20 degrees minus cosine of 20 plus phi degrees. And we can plug in this equation to the second equation. So here we have negative 90 times sine of 30 degrees plus t. Let's try to factor out t here into this expression. So we have t times sine of 20 degrees plus sine of 20 plus phi degrees equal to 0. And plug in this value into the equation, we will have a single equation with single unknown. In terms of phi, we have t equal to negative 90 times cosine of 30 degrees divided by negative cosine 20 degrees minus cosine of 20 plus phi degrees times sine of 20 degrees plus sine of 20 plus phi degrees equal to 0. And we can use our calculator to solve for the unknown value of phi. So you have negative 90 sine of 30 degrees plus negative 90 cosine of 30 degrees divided by negative cosine of 20 degrees minus cosine of 20 plus phi times sine of 20 degrees plus sine of 20 plus phi equal to 0. If solved, you can solve for phi that is equal to 20 degrees. That is letter D. Now that we have phi, we can now solve for t by directly substituting phi equal to 20. So we have t here equal to negative 90 cosine of 30 degrees divided by negative cosine of 20 degrees minus cosine of 20 plus phi, which is equal to 20 degrees, equal to 0. Wait, no. No need to put the equal sign. We have t equal to 45.69, or approximately equal to 45 to 70 pounds.